Hi dear friends, good morning one and all. Myself Bhavsab Sononi, Assistant Professor, Department of Chemistry, Gokhale Education Society, Arts, Commerce and Science College, Jawar, Palghar. Dear friends, in the previous lecture, we have discussed about the various characteristics of decay constant of radioactive disintegration of radio element. In that lectures, we discussed about the characteristics like unit of decay constant, which is reciprocal of time. Next, we have also discussed about the half-life period and mean or the average period of radio element. After discussing the characteristic, we have also seen the numericals based upon the decay constant and its half-life period. How can we calculate the half-life period or the time required any radioactive element? Dear friends, after discussing the characteristic and numericals, we had also discussed about the detection and measurement of radioactivity. Whenever any particular radio element undergoes disintegration, it emits some radiations like alpha, beta, or the gamma radiations. Then, how these radiations can be detected and measured with the help of various instruments, that was the part of our previous discussion. Based upon the same, today in this part of the lecture, we are going to discuss about the detection and the measurement of radioactivity. Dear friends, as we all know that nuclear radiations which are emitted by means of any radio element, these are of the different types like alpha, beta and the gamma radiations, and based upon these radiations emitted by the radio element, there are different types of radioactive decay, that we call it as alpha decay, beta decay and the gamma decay. But what happens whenever these radiations are emitted by any radio element, it is very important to identify these radiations, and at the same time it is also essential to measure this radiation. But the question arises, how these radiations can be detected and measured with the help of different instruments. This is the purpose of our today's lecture. General phenomenon which is observed here in the detection of these radiations emitted by the radio element is that whenever these radiations are passed through any inert gas, these are responsible to produce the ion pairs. Whenever we are seeing the ion pairs, there is a formation of two species. One is a positively charged species that we call it as the cation, and the another one is negatively charged species that we call it as the anion. So one is the electron deficient, another one will be electron rich species. So these ion pairs, in presence of an applied electric field or applied voltage, migrate towards the oppositely charged electrode and get discharged, and during discharge these are responsible to produce the current. From the magnitude of current produced, here we are able to identify the type of ionization, and from the type of ionization, definitely here we are able to identify the radiations or the particles emitted by a particular radio element. So this is the phenomenon, or this is the way by which we will be able to detect, and we will be able, so this is the way by which we will be able to identify the radiations, and we will be also able to measure these radiations based upon the type of ionization and the number of ion pairs formed in this case. At this, in the same lecture, we have seen that the alpha particles are able to around 10 raised to 5 ion pairs per centimeter, while beta particles are able to produce 10 raised to 2 number of ion pairs per centimeter. Again, The number of particles emitted by any radio element is detected and counted by means of two devices called as the counter. The first one is called as the GM counter, that is Geiger-Muller counter. These are the names of scientists who has discovered this counter or the device. And the second is called as scintillation counter. So today in this lecture, first of all, we will discuss about the first counter, which is used to detect and identify the type of radiations or the particles emitted by a radio element. And the first one is very important, called as GM counter. Actually, this GM counter works on the principle, general phenomenon which is observed here. When ionization chamber, what is ionization chamber, how the potential is applied to this ionization chamber, that all we will discuss in the working and the construction. But in this case, in the principle, it is observed that when ionization chamber has potential between copper cylinder which acts as the cathode and the tungsten wire which acts as the anode in the central part of this tube or the cylinder, in the range of 900 to 1400 volt, internal amplification take place, and this internal amplification is as high as of 10 raised to 8 times, and the number of ion pairs which are produced is independent of primary ionization, because in this case initial number of ion pairs are again responsible for the secondary ionization. That's why the initial ion pairs are formed due to the radiations are called as the primary ionization, and from this ion pairs, from this negatively charged species or the electrons, the second ionization take place, that we call it as secondary ionization. But the next pair of ion pairs which is formed here, it is independent of primary ionization. So once the primary ionization take place, the secondary ionization will get started, and that does not depend upon the primary ionization. So this is figure or the diagram that indicates the arrangement or the setup of GM counter. So here you can, in brief, I would like to tell you the construction or the this setup of this GM counter. So this is the copper cylinder or the tube. This is the copper cylinder or tube which is made up of a copper metal. Again, at the central part of this tube there is one filament or there is one wire which is made up of the tungsten. But before this, I would like to tell you here, this is the power supply. Now this is the power supply and this is the readout device. But if we'll see this power supply, then one end is connected to the wall of the copper cylinder and the another end definitely connected to the tungsten wire. So out of this, the wall of the copper cylinder or the tube acts as the cathode. It means it carries negative charge, while this tungsten wire, it acts as the anode. It means it carries positive charge. So here we can discuss about the construction and working of this GM counter. So this is the simple setup for the GM counter which is used to detect as well as to identify the type of radiations emitted by the radio element. So this is nothing but the tube in which inert gas is filled. So these are the molecules of inert gas which undergo ionization. These are the radiations emitted by the radioactive element. Whenever these radiations will enter this tube, the ionization take place, primary ionization take place, and this is the gate or this is the window to enter or for the entry of radiations emitted by the radio element. So once these radiations will enter this tube through this window, generally it is called as Mecha window. Definitely it is responsible for the ionization to produce the ion pairs. So these are the, already I told you, these are the atoms or molecules of inert gas which is filled in this tube. Again, this is the central wire, tungsten wire, which acts as the anode, and these are nothing but the ion pairs. Ion pairs in sense, this is the positively charged species and these are the electrons, mean negatively charged species, and this is the wall of the copper cylinder or the copper tube which carries negative charge, and this is the device which is called as the readout device. It is responsible to measure or to count the current or the amplified current here. So definitely it depends upon the number of ion pairs formed. So here this is in short the construction. Latest we can see here, just already I told you here, this GM counter, it is made up of metal tube, or it consists of metal tube made up of copper, which acts as the cathode, having its length of 10 centimeter, and the diameter of this tube will be 2 centimeter, with the thin mica window at one end. So this copper cylinder is having the length of 10 centimeter, while the diameter of this tube will be 2 centimeter, and this tube is having a mica window at one end, which acts as the entry point for the radiations emitted by the radio element. Again, the central part of this tube consists of the tungsten wire, which is having about 0.05 mm thickness, and it acts as the anode along the axis of cylinder. So this is the tungsten wire which is present at the center of the tube, and it acts as the anode, so it carries the positive charge. So definitely it's very important. So this wall of the cylinder acts as the cathode, it means it carries negative charge, while this tungsten wire acts as the anode, it means it carries positive charge. It's very simple. Next point is that tungsten wire is insulated from the copper metal cylinder. So you can see here, this is the copper metal cylinder. So this is the wall of the copper metal cylinder, and this is the tungsten. So this tungsten wire is passed through this window, passed through this wall of the copper cylinder. But here there is complete insulation between tungsten wire and wall of the copper metal cylinder. So there is no any connection between these two. One is the tungsten wire, and the another one is the wall of the copper metal cylinder. So here this tungsten wire is completely insulated from the wall of this copper cylinder. So this is the next point. Again, this already I told you, this cylinder is filled by means of some inert gases, and here the inert gases which are used here, these are nothing but the argon. So this cylinder is filled with a mixture of 90% argon, which is the inert gas, and 10% ethanol or bromine vapor. So remember that this gas cylinder is filled with mixture of 90% of inert gas argon and the 10% of ethanol or the bromine vapor. Definitely in the next part we are going to discuss about what is the function of 90% argon and what is the function of 10% vapors of alcohol or the bromine. These two are very important in this cylinder, in this tube. Definitely these are responsible. One is responsible for the ionization, another is responsible to prevent the unwanted avalanche that we will discuss in the working actually. But remember that this cylinder is always filled with the mixture of 90% argon inert gas and the 10% ethanol or the bromine vapors. So this is two component. These are the two types of the molecules which are present in this tube, in this copper cylinder. Again, argon is responsible to provide the ion pairs. So already I told you, this argon inert gas is responsible to provide ion pairs after the ionization due to the radiations emitted by the radio element. So this argon is responsible to provide the ion pairs, while ethanol or bromine vapor, which are also present in the same cylinder, acts as the quenching agent. So what is the quenching agent? Definitely that we will discuss in the working after the discussion of this construction. But remember that argon is responsible to provide the ion pairs, while ethanol or bromine vapor acts as the quenching agent. This is very important to understand this thing. What is the function of argon gas and what is the function of ethanol or the bromine vapor here? So remember that argon is responsible to produce the ion pair, while ethanol or bromine vapor responsible, or they act as the quenching agent. Again, there is one window which is the entry point for the radiations emitted by the radio element, means alpha or the beta radiations or the particles. This Mecha window which is present at the one end of tube. It is responsible to prevent the escape of gases from the copper cylinder into the atmosphere, and it allows the ionizing radiation to enter the cylinder. So this is very important characteristic of this window, is that it acts as what? It acts as the material which allows the only entry of radiation, but it prevents the escape of gases from or out of this copper cylinder. So this Mecha window does not allow the escape of these particles of argon or the ethanol or the bromine vapor out of this copper cylinder or this metal tube, but it only allow the entry of this ionizing radiations or the particles alpha and the beta particle into this tube or into this copper cylinder, which is responsible for the ionization. So this is really a part to understand here, that how this Mecha window works. So this is the one way point, this is the one way. So it allows the entry of only alpha and the beta radiations particles, or it allows the entry of only ionizing radiations responsible for the ionization of these gases, but it prevents or it does not allow the escape of these argon gases or ethanol or bromine vapor out of this copper cylinder. So it is very important to understand. So this is nothing but just the, here we can say that semi-permeable membrane, which allows the only the entry of solid molecule or the passing of solid molecule and not the other one. In the same thing, this Mecha window which is present at one end of this tube, it allow the entry of only ionizing radiation into the tube, but it does not allow the escape of these particles, escape of these molecules of gas out of this copper cylinder or the metal tube. So it was regarding with the construction. It was regarding with the construction of this GM counter, which is one of the device used to detect the radiations or the particles emitted by radio element, and how these are measured with help. So in this part of the lecture, we have discussed about the definitely the principle of working of the GM counter. At the same time, we have discussed about the setup, how this setup of GM counter, or what are the components of the GM counter are necessary for the detection of radiations emitted by the radio element. So these are the component. In short, that is nothing but, again I am going to revise here. It consists of the copper metal cylinder or the metal tube which acts as the cathode. It consists of a tungsten wire at the central part which acts as the anode, and these are connected to the readout device through a power supply. Again, this copper cylinder has a Mecha window at one end which allows the entry of only ionizing radiations, and it does not allow or it prevents the escape of inert gases out of this tube or out of this copper cylinder. Again, this copper cylinder is filled with a mixture of 90% of argon and the 10% of ethanol, which acts as the definitely two important components inside this tube. Out of this mixture, the argon is responsible to produce the ion pairs, while the vapors of ethanol or the vapors of bromine acts as the quenching agent. Definitely it will be a question in your mind, what is quenching agent, how this argon will be responsible to produce the ion pairs, or how these ionizing radiations are responsible to cause the ionization of these argon gases, inert gases in this copper cylinder, and how these are recorded in the form of count of the current after the formation of ion pair. Definitely it might be a very important question in your mind, that you will get answer of that question, all that questions in the during the discussion of working of this GM counter. So in the next part of this video, or in the next part of this lecture, we will discuss about the actual working of the GM counter, how it works, and what will be advantages or disadvantages of the GM counter. Definitely that will be the part of next lecture. So thank you dear friends, we will resume in the next part to discuss the working of this GM counter.